The camping lantern. It burns fuel, produces a flame, and that produces light. Simple enough. Actually, it's not that simple. That's because the role of the flame is not what you'd expect. It's not to produce light. It's to produce heat. This heat agitates the chemical elements at the center of the lantern, the mantle, which reacts by emitting a very bright white light. The mantle's special makeup utilizes two distinct phenomena to produce the light. First, common incandescence. Second, and most importantly, thermoluminescence, a rare occurrence. So how does it work? The camping lantern, the fuel tank, a pump, the pipe which brings the fuel to the flame source, and the mantle which surrounds the flame. To begin, the pump allows the injection of pressurized air into the tank. When the valve is open, the air pressure pushes the fuel, which flows through the pipe, all the way to the mantle. The fuel ignites on contact with the flame of a match, and the lantern is lit. But the light produced is actually 60 times stronger than the light of the flame. To find out what's going on in there, it's time to take it apart. The secret of the lantern lies within the mantle. The mantle is made up of a mixture of special metals: yttrium, a metal that remains stable when heated, and rare earth metals, which produce light through the extraordinary process of thermoluminescence. So, lantern lit, the flame burns in the mantle. But this flame alone produces very little light. It's mostly a source of heat. It heats the mantle to over 1000 degrees Celsius. The mantle can take the heat and responds to it like any other heated object would. The thermal energy from the flame excites the atoms of the mantle. The atoms agitate more and more, and part of the energy transmitted to the atoms is released in the form of light. The more agitated the atoms, the more light they give off. This is called incandescence. So, the more a body is heated, the more light it emits. And while it's a common occurrence, it's just not very bright. But the chemical components of the mantle also use the flame's heat to produce light through thermoluminescence, which is a rare occurrence. Not only are the mantle's atoms reacting to the heat to produce light, but the components of those atoms are also reacting to the heat and producing light. Some of the electrons that orbit around the nucleus of the atom become excited briefly when the mantle is heated, so they change position. But that excited state doesn't last long, and they instantaneously return to their starting positions, disposing of all their extra energy in the form of light. This method of producing light is thermoluminescence. The light produced by thermoluminescence is much more intense than the light produced by incandescence. That's how a lantern that utilizes a flame can produce a light 60 times more intense than the light of that flame. The camping lantern. It produces a flame, not to light, but to heat. So it can utilize the chemical makeup of its small mantle to produce an intense white light through the wonder of